In this video, I am going to solve the 10th question from chapter 16, Waves 1 from Principles of Physics, 10th edition. The tension in a wire clamped at both ends is halved without appreciably changing the wire's length between the clamp. So here you have a wire, and in this wire we apply a tension, and what they mentioned in the first line, you have to halve the tension. That means the tension is halved without changing the wire length. So that means initially its tension, let's we consider 1 Newton, and in this first line they mention you have to halve that tension. So now if you have the tension without altering the wire's length, what is the ratio of the new to the old wave speed for transverse wave traveling along this wire? So you have a wire. In this wire there is a transverse wave. That means the wave is traveling on the string, and here we are going to alter the tension to half of the value from the initial. That means in old, better we can write the formula first, by that we will get. So in the initial stage, let's we take tension old, let's we take T, and in tension new, what we did, we are half the tension. That means it becomes T over 2, right? Now by using this we are going to find what should be the ratio of the speed new over speed old. We are not altering the length of the wire. The string length is exactly the same for both cases, but we are going to find what should be the ratio. What is the ratio for the new speed over the on the string over the speed in the old case? As we already know, the formula for the speed, which is equal to square root of T over mu, right? This is the rule. Now what we are going to do, we are going to apply this rule for this. So by that what will happen, we will get, so better I can write Vn stands for the new speed and Vo stands for old speed, which is equal to, for the first case I have to write, in the new case what we did, we half the tension over mu, right? Because in place of the tension new we have to half, or I have to write one more steps here. So by that what will happen, this becomes square root of T new over mu over T old over mu. This is the rule, right? But here I just wrote N stands for new, O stands for old. Okay, so but in place of this new tension we have to half the tension as they mentioned in the question, divided by, in the old I did not touch anything. I'm going to write the same exactly as it is because we did not touch the tension, which is exactly T, right? Okay, better I can do one thing. Initially I'm going to squaring both the left hand side and right hand side. By that you will get a clear idea, because whenever you solve the question with the square root, sometimes it may be leads to confusion. For avoiding this type of confusions, I am just making one more steps more, right? So what I'm going to do, I have to discard this square root, so I have to squaring both left hand side and right hand side. So what will happen, Vn speed new square over speed old square, which is equal to T over 2 mu, right, over T over mu, right? So if you remodify this equation, what will happen, this part becomes T over 2 mu multiplied by this mu will come to the numerator and this T will come. So by that I can cancel this tension with this tension, I can cancel with this mu with this mu, this is mu, okay? So I cancel. So what is remaining? In the remaining we have speed new square over speed old square, that means old square, okay? Speed old and speed new, which is equal to 1 over 2, but they did not ask the speed square, they just need the ratio of new speed over old speed. So once again, I am going to take the square root on both sides because we need the answer of, you can easily find the answer from here itself, because why I just make one more step, just for the easiest understanding. Okay, so I have to take square root on both sides. So therefore, the new speed over old speed, which is equal to 1 over root 2. Clear? So this is the answer for this question. Understand? That's it.